All right, so you might still be working on the warm-up. That's totally fine. We're just going to start going through it and talking about it. So we're looking at relations and functions. Today we're going to determine how a function is a relation and how a relation is a function. We're going to work on graphing ordered pairs, mapping diagrams, and looking at tables of values. So the first thing I asked you to do was to graph those ordered pairs. So you're going to pull out your points. So we have point number 1, -4, -8. That tells you it goes left on the x-axis 4 units and down 8 units on the y-axis. So that's the point down there. 3, 6 tells you 3 units on x, 6 units up on y. 0, 0 is a special point. It is known as the origin. It is the center of the coordinate plane. It is where the x and y axis meet. -1, 3 goes left 1 on x and up 3 on y. And -6 goes 6 on x and up 5 on y. Okay, and then we talked about evaluating each of those at each of those points. So what you're doing is plugging in -1 for x each time. 0, 2, and 5. This is kind of like making a table of values. So when x is -1, y is 1. When x is 0, y is 2. When x is 2, y is 4. And when x is 5, y is 7. So it's kind of like your x and your y's. So when x is this, y is that. The middle just shows the work. Okay? Number 7, plugging in -1, you have -2 times -1, -2 times 0, -2 times 2, -2 times 5, and we're adding 3 each time. A negative times a negative is a positive, so 2 plus 3 is 5. 0 plus 3 is 3. -4 plus 3 is -1. And -10 plus 3 is -7. Now we're going to square each term and then add 1. 1 squared is 1. -1 squared is 1 because a negative and a positive are the same. So 2 times 1 is 2. 2 plus 1 is 3. 0 squared is 0. 0 times anything is 0, so we get 1. 2 squared is 4. 4 times 2 is 8. 8 plus 1 is 9. 5 squared is 25. 25 times 2 is 50. 50 plus 1 is 51. And then your absolute values. So we have the absolute value of -1 minus 3. So it's the absolute value of -4, which is 4. 0 minus 3 is the absolute value of negative 3, which is 3. 2 minus 3 is the absolute value of negative 1, which is 1. And 5 minus 3 is the absolute value of 2, which is 2. Questions on that? Fantastic. So that kind of leads us into today. We are talking about a relation. Relations are a set of ordered pairs. A relation is a set of ordered pairs. A discrete relation is a relation in which the domain is a set of individual points. A continuous relation is a domain of a relation in which they have a nice, smooth, graphed line. The domain is the set of x coordinates. The range is the set of y's. So in the example 2, 3, 1, 8, 0, 7, and negative 1, 4, the domain was all the x coordinates, or negative 1, 0, 1, 2. The range was all the y coordinates, which were 3, 4, 7, and 8. Anybody need more time? Okay. All right. So what we want to do is graph each relation and determine its domain and range. So 0, 4, negative 2, 3, negative 1, 3, negative 2, 2, and 1, negative 3. So our domain is our x values, which are negative 2, negative 1, 0, and 1. The range is the y's, so negative 3, 2, 3, and 4. This is not continuous, therefore it is discrete. And that's because these points right here would not connect in a smooth fashion. These points here would make our graph unsmooth. Okay, on the right, we have negative 2, 1, negative 1, 0, 0, 1, 1, 2, So our domain is -2, -1, 0, 1. Our range is 0, 1, 2. This would be continuous because if you look, I can take these dots and connect them and they will form a nice absolute value function, which looks like a V. We can do the opposite. We can write down the coordinate points. So in this graph, we have several points. So the ordered pairs or the relation is -4, 4, -2, 4, -3, -2, 3, 2, and -4, 2, -4. So I have 5 ordered pairs. I have 5 graphing points. My domain are my x values. My range is the y's. I never repeat a value. So even though 4 is in the range twice, I only write it once. And this also appears to be pretty discrete. There's no rhyme or reason to where the points are or how they're jumping around. In example 4, you have the point -3, 2. You have the point 0, 1. We have the point 2, 4. And we have the point 4, -3. Remember, a relation is a set of ordered pairs. So you need the set notation. Same with your domain and range. They are a set of values, so they get that squiggle around them. And this one's a little tricky. I could kind of go with either if you told me continuous or discrete, because you can connect them and smoothly connect them. So this one's kind of one of those hard ones to tell. So I would take either answer. Okay, and then the last thing, again, also a review. We kind of talked about a lot of this in chapter 0. A mapping is where you map from one side to the other. You label your domain on the left and your range on the right. So we have -1 and 1 in our domain. I have 3 and 7 in my range. And I map from the left to the right. So -1 maps to 7. 1 maps to 3. If we stopped here, this would be a function. However, 1 also maps to 7, and -1 maps to 3. Therefore, this is not a function, because for every x, there is not a single y. So this is a relation, but not a function. In 6, you have 0, 1, 2 in your domain. 2, 3, 4 in your range. 0 maps to 2, 1 to 3, and 2 to 4. So this would be a function because for every x there is only one y. So from the left to the right, there is only one arrow from every left value. So here we have -1, -2, 0, and 2 in our domain. I have 3, 5, and 8 in my range. +2 maps to 8. -1 to 5. 0 to 8. -1 to 3. And -2 to 3. So again, this is not a function because -1 goes to 2 values. It goes to 3 and 5, which would also mean that this is discrete. So you can't have that duplicate on there, so that would make this a discrete function. So if it's not a function, it's discrete. Okay, your homework is on those next few pages. Your homework is on that page 65. You are looking at 4, 14 to 17, and 23. So it's literally the next page in your packet. Okay?